Welcome, software engineers, to day 12 in CSC 222. What's the name of this course again? Oh, that's right, software engineering. AI is one of those things that seems really cool and sexy, but software engineering is what gets the job done and pays the bills. Upcoming attractions, just in case Blackboard is recalcitrant and you can't figure it out because I couldn't figure it out. Today we'll be talking about assignment 14. You'll see an article online at Blackboard. The second out of 3 or maybe 4 articles we'll read by Fred Brooks. This one entitled No Silver Bullet. So I'd like you to read through that. I'm going to say some things about that today. And then the activity associated with it, assignment 14, is due next Monday, 1 week from today. Today, at the end, we're going to talk about assignment 13. I had a couple questions I want to be sure I address. I want to go through the requirements and specifications with you carefully. I want to show you a couple different code snippets that might help do a couple things there. But assignment 13 is due this Wednesday, 2 days from today. And then the CNCS assignment, Christianity and Computer Science, dealing with the 5th commandment. We'll say some more things about that today too. And that's also due on Wednesday. So thanks for keeping track of those things. I know there's a few things and we're kind of offset here a little bit, but darn, not sure what Blackboard tells you when things are due. Otherwise, ask. I'd be happy to tell you too. You wrote that your objective for the year is to obscurely toil to increase the unearned wealth of our parasitic stockholders. I'll add, and managers. We've seen now that when I use the word management in the context of software engineering, I'm certainly not talking about Dilbert's manager or other stereotypical bad managers like that. We're talking about management in a good sense, understanding the process, monitoring the process, and planning the process. Good. We're up to our 5th aspect of professionalism. And as I shared with you last time, being cool and calm. And, you know, I'm not joking. If you have a better term for these, I'd love to hear it. Doesn't mean A, that I'll use it, or B, I'll give you any credit for it. Nah, if you give me a better term, I'll certainly cite you in that. Do you know what I mean? The problem is cool and calm is somewhat a colloquial phrase. And non-native English speakers might mistake that for being cold in the state of Wisconsin. Cool and calm under pressure, under fire, especially. Yeah, composed. Okay. Yeah, that's a good word. I like composed. Not sure about that. Yeah, composed. Because I bet you can actually look that up in the dictionary and get a good, oh, shoot. Now, I said something that woke up my, excuse me just a minute, that woke up my voice recognition app. Go back to sleep. There, we'll see what it does. Oh, yeah, I see. It's throwing that in. Okay, thank you, Ryan. Let me think about being composed. I gotta look up what it means first, though. Then we'll see if it fits. 5th commandment, we saw that last time, you shall not murder. Your boss says you refuse to do your job. He told me to kill a customer, assume her identity, and place a huge order with our company. I'll transfer you to the collections department until you're willing to kill. I'm sorry, it's not funny, but Catbert, the evil director of HR, is the most hilarious person. No, you can't call a cat a person. Is the most hilarious character in Dilbert. Probably because if you've worked in a medium to large size company and had any experience with HR, you know it's all true. What Catbert says is entirely true. Would anyone in the group care to comment on the way Frank is dealing with his anger? Yeah, cool and calm is the opposite of anger. And I think composed can work pretty well for that. I'm going to have to remember that and figure out. You recognize when you read the fifth commandment, especially the explanation of the fifth commandment as Luther put forth, that it's just not limited to physically killing someone. Jesus made this abundantly clear in the New Testament, where he told the Pharisees, you say, do not murder, and you're correct. But I tell you, anyone who hates his brother has murdered him in his heart. So it's about the internal attitude, not just the outward action and expression of that. Note well what Luther says. We should fear and love God so we do not hurt or harm our neighbor in his body, but, positive, help and support him in every physical need. Can you relate that to being composed, being cool and calm? And how can a software engineer carry that out? Yeah, of course. If you were creating some kind of weird app that was going to end up killing, yeah, I think we know that there was something wrong with that. But do our apps help and support our neighbor in every physical need? Something to consider. And thank you for doing that. I've appreciated reading your feedback to the CNCS assignments. Hopefully it's helpful for you to make that connection also. The pointy-haired boss is testing our self-driving car prototype. Hey, didn't you write the operating system for that prototype? Yes. Hypothetically, could you murder him from a distance? We shouldn't have this conversation. The government forced me to put a kill code in the operating system for a self-driving car. Dogbert. And by kill code, you mean it will bring the vehicle to a controlled stop? No, you're thinking of a stop code. Okay. I don't know why. It just comes up all the time. So last time we began Unit 2, implementation phase. And we began an overview of design. We want to talk more about design today and think about it in the context of what we're doing also. I can't help it. One of my favorite words, instantiate. The implementation phase, it's all about to instantiate the idea. And thankfully, here is the dictionary definition of instantiate. Represent. To represent something, a model or an abstraction, by a concrete instance. Take this mental model, take this paper, take these diagrams, put it all together in something real. And for us, real is software implemented in hardware. Yeah, sorry, too many of these. I find them, I think they may actually apply to what we're doing. But then I just discovered, no, I just thought they were funny and they didn't really apply at all. So please ignore this one. I meant to look this up and I started, and for some reason, I got sidetracked. So I'm going to ask you a serious question. At Concordia University, Wisconsin, we have a tool as part of our MY collection of stuff called DegreeWorks. What DegreeWorks does is to allow a student to determine how much of their current degree they have satisfied, what courses that are required have actually been fulfilled, what courses are required need to be fulfilled, and then for electives and minor, what courses fit in there, etc. Many of you, I think, are sophomores and juniors. And it'd be time to start thinking about, am I on track? This is just part of managing and planning myself. Does anybody know, do you have a similar tool? If you go to and again, I went there too, but realize it may not be visible to me as an instructor. Do you have something similar to DegreeWorks, something that will tell you what courses have satisfied your degree requirements so far? Ah, you do. Got DegreeWorks? Excellent. I'm going to encourage you to do something. I was tempted to make it an assignment, but I want to encourage you to run it now. If yours is like ours, you have to kick it in the head again and say, do it again if you've already did it once. But run that out and just see where you are. Talk to an advisor. I see so many things I don't know. I don't know if Professor Tallman serves as an advisor, or do you have other folks that serve as academic advisors, staff level people? Don't need to tell me, I think you know. But I would encourage you to run this and just see how you are doing. You don't want to be surprised. At Concordia Mequon, I force my students to do this 2 times, once in the middle in a class that's usually ending sophomore, beginning juniors. And then I teach the senior theory course that starts at the beginning of their senior year. And I do this right now, and let's look at it. You don't want to be surprised 2 weeks before graduation to discover that, oops, you're missing something. It's just part of managing. It's part of planning. So since software engineering is part of planning and managing, it goes together. That's a weird picture. For some reason, I'm a freshman. Oh, thank you. Do it. So last time we started the design overview. How do we get from the idea of software engineering? And the idea is expressed in 2 things, 2 phases: requirements and specifications. How do we get to that to implementation? How do we make this abstract model of our system very concrete? How do I get it into code that actually solves the problem? That's what design is all about. So what's the purpose of the design phase? Key word to remember with design is how. How will the product solve the problem? As we'll see in just a minute, I mean very explicitly. How will the product solve the problem? It's not the what's. The what's we're taking care of in specifications. The why's we're back in requirements. How's the product going to solve the problem? Now, for us as computer scientists, then, our focus, what do we mean by how? We mean creating specific algorithms and actual data structures. You have to plan the algorithms and the data structures. I want to say, as we'll see in a minute, why don't we just go see it? I did share with you, I think at the end of the first unit, the importance of planning. I shared with you a quote from President Eisenhower. Plans are useless, but planning is indispensable. Same thing with DegreeWorks. I mean, I don't know about you. When I was an undergraduate, and yeah, there were colleges way back then, I made a plan. I said, look, this is what I want to do, and I want to be done in 4 years, and this is how I'm going to get there. Well, guess what? It changed for a number of different reasons. I changed my major at least 4 times. And you know how something comes up. I got married, things happen. So that plan went, but if you don't continue the planning process, you'll never get to your goal. Solomon, I think 21 is Solomon. There's a couple chapters of Proverbs that were not written by Solomon, but I think they're later. The plans of the diligent lead surely to abundance. In context, diligently plan. Plan and re-plan. You bet. Just do it. What do you think of my plan, Alice? I'll bet your left brain is so tiny that you stagger in a clockwise direction. I'll ask someone else. Walk towards the credenza and you'll have a good chance of hitting the doorway. So much unprofessionalism as exhibited by Dilbert. Is it helpful to see what not to do? Good. I've never understood this proverb. The best laid plans of mice and men. Do mice make plans? The best laid plans of mice and men often go awry. That is true, except for Chuck. Even the worst laid plans of Chuck come off without a hitch. Won't be us. Don't feel badly. Replan. All right. Before we can actually see what's going on in design, I need to share with you something about the nature of instructions. The word instructions is a very big, broad word and can apply to lots of things. Human directions, computer algorithms, etc. Let's discuss two types of instructions. One type of instruction is the type that human beings deal with. We call the directions or instructions that we work with declarative. Declare means to state what to do. You know, this is how people give instructions. And this is what I've done in every homework assignment for you. I've told you exactly what to do. The declarative instructions are the things that we find and we wrestle with in requirements and specifications. Notice that they tell us what to do. Here's the problem. Flippantly, I could say, if you come to me with a question about a homework assignment, I don't understand why you have a problem. I've told you exactly what to do. And that's true. But the problem that you have is figuring out how to do that, because I didn't tell you how to do it. And guess what? Determining the how is like really hard. The other kind of instructions then we call procedural. And you hear and see the root procedure in there. Procedural instructions are algorithms. By definition, an algorithm is a set of, there's some adjectives, detailed, unambiguous set of step-by-step procedures for solving a problem. The exact specific things to do. And this is what's happening in design. In design, our task as software engineers is to create procedural instructions. In other words, we're not going to say what to do. We're going to say how to do it. And this is hard. Example. Let's say that one of the specifications in my specifications document is we need to sort a list of records in key field value. That's good enough for a specifications document. If I say sort, I'm saying what to do. Sort the records in this file in key field order. That's a declarative instruction. That's not for design. In design, you're not going to write down sort the records. Nope. You're going to have to say exactly how to do that. Sometimes, if I'm very mean, and you know I'm not mean, so I won't do it. No, actually, it's so hard to do at a distance because I want to look at you and show you that I'm serious. Imagine if I asked you to create the design for a sort now. What if I gave you a prototype? I want you to sort num. Okay. Well, what's that really mean? Well, what we know it doesn't mean is just write the word sort. You can't write the word sort. That's not design. You're going to have to tell it, here's how to sort that thing, that struct known as num. Okay. You've been sufficiently shocked and awed, and now it's burned in your mind. Oh man, I can't just declare something in sort. I actually have to write procedural instructions. Do it. No doubt you know there are many ways to sort. This, of course, is a classic, what did you call it the same thing? I call it a bubble sort. I've heard it called different terms. You've seen sorting algorithms. Here's a classic bubble sort. Now, if you look at this, you may realize this is not really C#. I mean, it's close to it, but it certainly is not C# at all. That's okay. These are procedural instructions. Last time I called it PDL, Program Description Language. Some people use the phrase pseudo code. But notice how detailed and how procedural it is. It's saying exactly what to do. Now, some of this, swap. Is that a method? What's temp? Is that some kind of argument? Well, there's still some things to do. But yet, if you are an accomplished programmer, you can look at this and say, yeah, okay, I can actually instantiate that in my favorite programming language. Good for you. Know the difference then between declarative and procedural? At a certain point in time, we are going to actually have to write the code. Now, this is not design. This is the next phase. But at some point in time, we are really going to have to write code. And we say, hey, okay, that's a little more detailed, a little more precise, less ambiguous than the design. But yet, this could be drawn from the design without a whole lot of pain and suffering by the programmer. True? I wonder if that really works. All right. There's an even better way. Even better way is, heard this if you read the Fred Brooks article, the first one, Mythical Man Month, heard a little discussion of this, and we'll see it again. Rather than writing your own sort, let's reuse somebody else's sort. Let's just use a built-in method. Now, if you didn't know such things existed, there's a reason for that. That's because as students learning about computer science, we want you to have a deep understanding of these things. You need to understand sorts and linked lists and a million other things for sure. So actually hacking out that code is beneficial. It's a good learning experience. But if we were going to do this in industry, I wouldn't want to write my own sort code. There is likely either a built-in library, or maybe even your organization has some built-in, some methods that have been created locally and then are used for various tasks. Did I have another one? Oh, yeah, okay. So if you didn't know, I can sort an array, I can sort a list, I can do a lot of different things, and feel free to look those up. The point is, by design, Has to be very procedural. Unless I know for a fact that I have a built-in method accessible and understood by everybody, then it would be just fine. That'd be okay. You could just say array.sort. Yep, good. Some things that I said at the beginning of Unit 1, let me say here also at the beginning of Unit 2. Document every phase, and most milestones are documented. Why am I pausing and saying this? Some people believe that documentation is a separate phase. Maybe it's something you do at the very end of the project. Okay, when I'm all done, I'll write down what I did. It's not going to happen. That never happens. When you're all done, you're put onto another project. Now, there won't be time to sit back, contemplate, and say, I could have done this better. Let me write that down for the next time. Document each phase as you're doing it. Requirements, and we saw that, right? There's requirements document, specifications, a spec document, and a planning document. Design, same thing. There'll be some documentation. Now, the other thing that happens in each phase seems strange. Test. If you're thinking testing is only something I can do with code, think again. You can test at every phase. I didn't focus on that, although it was in the text. I didn't focus on it in unit 1 with recs and specs. We'll bring that up a little bit more here, and then we'll come back to it in Unit 3 to see what that really means after we've seen all of it and actually experienced it. You can test design. You can test specifications. Now, you're not running code, but you can test. And it's important to do so. And you're going to read a little bit about this in Fred Brooks' article about testing the fidelity of the representation. What did he just say? Testing the design. How would that work for us? Well, think about what we've done in the requirements phase. How would I test it? How would I test that running total idea? Well, first of all, I would ensure that I understood why there was a problem and why generating a running total actually solved the problem. That form of testing would be communication. I just got to check with the user, ask, double check, make sure we're doing it. Now, another thing that could be done, and we actually did this, is to create a proof of concept. A little bit of code that demonstrates that the idea is sound and can actually be instantiated and put into a product. So we did that. And that's okay. We can move backwards and forwards. This is not the waterfall. Even though we're in specifications, is it okay to do a little bit of code? It absolutely is. Okay, so we could say the same thing in specifications, same thing in design. We'll see that there are aspects of testing that can happen at every phase. Design testing is interesting, and it deals with algorithmic proofs. That is a topic for, I mean, that's a senior level course that at Mech 1, that's theory of computer science. And if you never deal with program proofs, well, your life is probably okay, but it is a really interesting subject. We've talked about milestones in requirements and specifications. There's The only reason I'm calling design levels is because not only are there milestones, but they sort of fit in a hierarchical sense and way. So if you like the term milestone better, it's more consistent, that's okay. I'll just call them levels, as we'll see. The highest and most abstract level of design is called architectural design. You've probably heard a job title as a software architect. The person who is putting together the high-level design of this entire product. Oh, I shouldn't have used high level there. Putting together the architectural design. Then you'll hear about high level design. Architectural design would list every module and its interfaces. In other words, it would list every method, every object. What's everything I need to do here? Now, after that big roadmap look at design, then we can look at individual objects, modules, or methods. Those are all synonymous terms here. High level talks about, just that. And notice, then we move to detail, where I'm going to fill in the details. You can read more about it, but let me give you a resource and let's actually do some things related to these different levels of software design. So software design is not just one thing. It encompasses architectural design, high-level design, detailed design. And by the way, not every software engineer nor every company uses these terms. It's also common for folks to just talk about two different types or levels of design. So just as I said for the entire 6 phases here, don't be upset if when you are a practicing software engineer, your company doesn't call it requirements and specifications, design, etc. They'll be doing those. They just may have different terms for them. In the first unit, I shared with you a design pattern, the running total design pattern. That idea of a running total is a very common problem. Therefore, rather than everybody on the planet solving it and maybe, spending a lot of time, energy, resources doing it, we have quantified that into something that software engineers call a design pattern. Design pattern. Design patterns are solutions to generic problems in software development. Design patterns are solutions to general problems in software development. How often does running total come up? A lot. Just like some other ones, request information. That pattern is used all over the place. Another way of thinking about a design pattern, this is a typical solution to common problems. You might have to tweak the pattern for your specific instance, but starting with a pattern is a lot easier than just trying to dredge everything out of your mind on how to solve the problem. Note that design patterns are heuristics. They are guidelines. They're not strictly algorithms. You have to dredge out the algorithms from the design pattern. It's a guideline. Another term you'll hear is the idea of best practice. Best practice is something that people believe experts use. Someone who is really proficient, a really outstanding software engineer, will use design patterns. It's a best practice in the industry. Just like reusing code. Why create the same thing over and over again? I shared with you in the first unit, output. That's basically a design pattern. When you're writing something out or a message box or anything else, you're not writing all the code for that. They just call it a method. Yeah. Good idea. Okay. Abstract, not for, yeah. Okay. That's enough. That's enough. Let me share with you, you'll find lots of things related to design patterns. What's good? What's fluff? Not always easy to tell. Refactoring guru. Design patterns. Design patterns are typical solutions to common problems in software design. Each pattern is like a blueprint that you can customize to solve a particular design problem in your code. Benefit, toolkit of solutions to common problems, software design. They define a common language that helps your team communicate more efficiently. List of 22 classic design patterns grouped by their intent. Look inside. All right. Who invented patterns and why? Learn more. Okay. Oh, hey, look, there's even a book. If you're interested, there are some good things online that will talk about it. And there's also some fluffy things online that talk about it. Maybe even the text talks about it. Oh, good. Zeb, I just don't understand cloning. Zeke, yeah, that makes two of us. That makes two of us. That makes... When I'm teaching a 75-minute class on campus, I do this weird thing. Oh, you've already seen me do plenty of weird things. I like to ask people to stand up for 60 seconds. I used to give people a 2-minute break, and sometimes they'd walk out of the room, and then I'd see them 10 minutes later, so you can't do that. Yeah. But they're sitting for 75 minutes is just really not good. Right? There's great health benefits to just standing up, even for 60 seconds. So I'm going to try to remember to do this. And if I forget, will you help remind me? It'll be okay. Look, some people think that's funny. Thank you. I'm going to ask you to stand up. You don't have to turn on your camera. Just stand up and walk around for 1 minute. Look, I'll turn off my camera. You'll feel better. Okay, are you ready? Stand up for 60 seconds. Come back. I'm going to do it too. Up. The other problem is purely selfish. See, my watch will not record and during this hour that I stood up. So now it will do that. Oh, no, but I have to stand for more than a minute to do that. How are we going to do that? Whew. I don't know. Do I have something else funny next we can see? No, that's not funny at all. Yay. Okay. My watch told me I had stood up. Someday we'll actually investigate the health benefits to not sitting for It's funny. I've done this for a very long time, and I always have students. I had a student come back to me who just was doing physical therapy, and the physical therapist told her, you should not be sitting for more than 45 minutes at a time. Nobody should sit for more than 45 minutes at a time. And she told me, oh, I thought about you. See, it's good science. Speaking of good science, design is hard. This phase, when done correctly, is the hardest part of software engineering. When done incorrectly, it's impossible. Design is hard. Everybody has recognized this since the dawn of software engineering. And everybody asks this question, well, can't we make it easy? It's hard. Can't we make it easier? Isn't there some tool? Isn't there some technique? Isn't there some magic that we can apply to make design easier? The answer is no. Online at Blackboard, you will see this classic article by Frederick P. Brooks, Jr., the same author of Mythical Man Month, No Silver Bullet. Fred Brooks has about 4 classic articles that a software engineer just says the title of it. Everybody knows exactly what they mean. Now, this is a little harder read because there's some philosophical stuff going on there. Essence and accidents, that's following some philosophy. Essence means the heart, accidents means the incidentals. I'm going to ask you to read this article. Let me preview some things with you. First of all, the term silver bullet, if you're not familiar with that, a silver bullet is used as a magic solution. Do this, all our problems are solved. That's what silver bullet means. It comes from mythology. The only way to kill a werewolf, I think, is with a silver bullet, right? In this article that you will read, Fred Brooks argues that the essence, the guts, the heart of software development is hard. And what does he think the essence of software development is? Requirements, specifications, and design. It's hard. He'll say there's no silver bullet. There's no magic solution to fix that problem. Of course, of course, Chuck doesn't need no silver bullet. Exactly. This is what Brooks says in that article. I believe the hard part of building software to be the specification, design, and testing of this conceptual construct. Stop there. What's that? Well, he does not have a separate requirements phase. I do. And by specifications, he means requirements and specs. Req, spec, and design. Okay? That's the hard part. Notice this, not the labor representing it and testing the fidelity of the representation. What is this? He's talking about coding and unit testing. He's talking about writing the C# and then running it. That is easier. That's not the hard part of software design. We're going to come back to that. Didn't we talk about that? We did. Sorry. I wondered where that was. Chuck Norris' first job was as a paper boy. Man, remember, Chuck is kind of an older guy like me too. You would not know at one time there were newspapers. Wow. And people used to deliver them. They'd roll them up and throw them on the front porch and things like that. Ask your grandparents. Chuck's first job was as a paper boy. There were no survivors. When that paper is going 210 miles an hour, man, you got to watch out. All right. Said this last week. Let's say it again. Just keep this in mind. What is good design? Good design meets the specifications. There's a way to test design. That's truth. Good design works well. Doesn't just work, it works well. That's goodness. It's aesthetically pleasing. It has beauty. And it provides a good user experience. That's my transcendental of community. Good design satisfies those requirements. It's a lot to think about. Good design is more than just, okay, let's make sure we sort this correctly. There's a lot to think about in the context of design. I have a new job for you. Our product is defecting and it's killing customers. You want me to organize a recall? Nope. Engineer a fix? Nope. You'll need overall, several barrels of bleach, and some sort of scrubby brush. They're fixated on this. All right. Do I have, well, I got a little bit. The fourth article we'll take a look at from Fred Brooks. Now we're just looking at number 2 right now. So the fourth one in the future is called The Design of Design. And one thing Brooks gets in there, and I'm going to augment a little bit, is good design is not by chance or accident. You've heard some classic stories. This is Archimedes sitting down in the public bath. The water spills over and he yells, "Eureka! I've discovered it." Right? That's not exactly how it went. Now, it may be true that in a flash, Archimedes got some insight, but he had been spending an enormous amount of time thinking about contemplating the problem beforehand. You don't know the problem. It had to do with the king wanted to know. He gave a bunch of gold to the goldsmith to make a crown. The crown came back and the king got suspicious. Did the goldsmith use all the gold or did he put lead inside? Well, he didn't want to melt it down and offend anybody. So he asked Archimedes, how could I tell if this crown is pure gold or not? So Archimedes thought about that, experimented, did something, and then, the idea of displacement of mass came to him as he sat down in the bath. Another scientist, not quite as old as Archimedes, this is Louis Pasteur. Louis Pasteur was very adamant that, okay, he wasn't thinking about software engineering, but I am. Good design is not by chance or accident. Good design doesn't just happen, doesn't just come to us in a flash. There's no silver bullet here. This is what Pasteur said. Chance favors a prepared mind. In other words, it's possible that you'll get some insight in a flash, but only if you are cultivating the ground, doing the hard work. And yeah, sometimes after all that hard work, it hits you in a flash. But it's not really an accident. It's not just by chance. Chance favors a prepared mind. So prepare your minds. Good. Yeah. I love teaching at liberal arts institutions, which is kind of strange because I'm not a product of liberal arts schools. I mean, Cal, my undergraduate, and Idaho and all my other places were not liberal arts. They were engineering schools, professional schools. But there's great power in the liberal arts, especially for computer scientists and software engineers. The liberal arts, we celebrate diversity of education. We want you to be well-rounded. Back to degree works. I have students ask me all the time, why do I have to take history? Why do I have to take English? Why do I have to take this and that and the other thing? It's so you have a broad base of education such that you can then effectively solve problems. You solve problems when you see these connections. We don't have time to take a trip down memory lane to look at the history of the development of a computer system, but it probably makes sense to you that I'm going to tell you that the founders of computer science and the creators of the modern computer did not have degrees in computer science. They created the discipline. They were all liberal arts people with a broad-based background. They were not geeks. They were not math nerds. They were liberally educated folk. So, you're at a liberal arts school? Good for you. Oh, cool story. Don't have time. Man, I don't want to shortchange this. Can I come back to it? I just want to make sure that let's do this first and then see if you have questions, we'll just do it. And if not, then I've got some things to use up at the end. First of all, let's jump into Blackboard and let me review with you assignment 13. Okay, due Wednesday. First of all, ensure your app meets all Sprint 3 requirements. So look back at assignment 11 in the previous unit. If you didn't get a perfect score on that and did submit it, then look at what I said there. Make sure it meets everything from Sprint 3. Now add these two major things, and they're not tiny things, they're pretty important things. Implement a save and print feature. This will be a menu item. I didn't say that before last time. I do want it to be a menu item. You implemented print in Sprint 3. Now it's not only going to print by displaying something, it's also going to save a file. Save will create a file on storage that contains a record with a timestamp. And you do that using a built-in method. Okay. The weight and the shim, the weight of the shim and the count of the number of shims. These values here you calculated, right? The total weight and the number of shims. Those are things are calculated and displayed all the time, and you'll put that out. All right, we'll come back and look at that. And then the next thing to do is to validate the undo feature. You will either allow only one undo, or you can allow multiple undos. Of course, that's harder. Now you're going to have to keep a struct that's going to contain all the past items in it. I would encourage you to make an effort at doing that. But the alternative is you can just allow one and either gray it out or alert the user. But let me show you how to gray out something. Provide good information on the help menu if you did not already. Blah, 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 blah. Think about what's happening and the same old as far as what you're uploading there. All right. Let me show you these two things, and then I'll open it up and see if you have any specific questions. Okay. First of all, let's go to this handout that's associated with the assignment. Write files. Write to file using Stream. Read more about it here. Here's basically the code that does it. Now, this doesn't solve the problem for you. You have to put a date and timestamp in. And of course, you're not just putting first line, second line, third line. You're putting values. So you're going to create a text file, something that has a TXT extension. Here I called it write lines. I don't know if write lines is a good name for it. Maybe you've got a better name for it, but you'll notice it's a TXT. That is a pure ASCII file. There'll be a single record, one line. That one line will have three items: the date and time that it was created, the total weight of all the shims, and the total number of shims. I encouraged you last time to just create something that does this so you can experiment and see what happens. All right. This is getting the location of the My Documents, AKA the Documents folder on your Windows installation. And it will just automatically put it there. And that's okay. That's okay. That'll work for me too. Alternatively, you could use the save file dialog method, and that will bring up a save as window. You're familiar with those in Microsoft Windows? And that will allow you to both spec a name and a location. But this should also be a TXT file. It's going to be an ASCII, a pure ASCII file. So what you need to do in assignment 13 is when the user issues the save and print, you're going to actually create a physical file, a real file in your system. That's something that afterwards you could open up. We're working in Windows. I couldn't remember the name of it. Notepad. Notepad is the classic text editor, and there's a couple other ones that will do it too. Typically, Notepad opens up .txt files. So after you run this, then you can exit out of the app. You could go to the location, whether it's Documents, My Documents, or it was specified by the user. And then you can open it up and see, did it work or not? Before we look at that graying out thing, are there any questions about what I'm looking for here in assignment 13? So I skipped to the second one, the right to a file. Any questions about that? If they come up, post it, chat, send me a message, whatever it takes. Let's take a look at this gray out a button idea. I wonder if I should show you mine first of all. Well, okay. Let me show you an example. Sorry, I haven't been able to do this as often as I've wanted to. I've had some problems trying to get, well, I could probably show you what the problem here is with my parallel setup Windows on top of my Mac. My IT support department has been supposed to give me a fix for this for quite some time. And I mentioned last time, and I'm still waiting on Irvine's IT support to give anybody who wants one a license for Microsoft Windows, maybe as a Christmas present. All right. Oh, didn't I leave that running? Guess not. Okay. Oh, maybe because I wanted to show you. All right. Here's an example of assignment 13. There's a couple things wrong. I'll point those out. I think you can see that, right? I think I've grabbed the entire Windows window. Would somebody let me know, can you actually see this window that popped up that says Add Shim's application on it? Thank you. All right. Now, a couple things from before. Notice that the focus is sitting right in here. I don't have to click in there. I can type in a value. But I do have to make sure it's started. I can type in a value, and I can click Add. That'll work. Notice the focus goes back. It clears out the previous, the 0.2 was cleared out. It's right there. I can type in another value. I can press the Enter key, and I can just keep doing this. All right. All these shims are approximately, somewhere around 1/4 pound, 0.2, something or the other. Great. Oh, all right. What if I typed bad thing? Please only enter positive numbers. That's telling me. Okay, 0.23 minus 0.34. Zeros and negative values are invalid. They're actual numbers, but they're invalid in this application. And then notice again, when the user types in something correct, that this goes away here. All right, here we are. Now, first of all, let's say, oh, that last one, no, it wasn't 0.34, darn. So let me undo last. Notice that it pulls it away. I'm back down to 5 rather than 6, and I'm back down there. So now I type in what the correct value is. Did you see what happened? After I select undo last, that button is grayed out. I cannot select it. But as soon as I do something good here, it came back. Woo! How'd that work? Oh, by the way, I really want this on a menu item rather than a button, save and print. And I'll show you, here's where mine blows up. Save and print. It's thinking. Windows cannot access /Mac/Home/desktop. Yeah. When they set up my parallels, they misconfigured something. I know what to do. The problem is I don't have a license key for either Parallels or Windows because that's my IT support department. So I'll wait for them to do it. Well, anyway, oops, cancel. So here's the classic. This is yours. Yours could do this if you want to. Here's the classic save as. Notice it's going to be a text file. That's what I've set it to. And now you can figure out where you want to send things. And you can call it something. And you can click save. I can't tell if I clicked it, I did not, or it's going to blow up. Yeah, it just doesn't like that. Now it's going to blow up. Okay. Unhandled exception. I know. All right, let's take a look at that idea of graying out a button. Let's look at some code to do that. Oh, man. Oh, darn. Okay, I gotta find it. Oh, wait a minute. Did I put it here? No, that's not what I want. Okay, sorry, folks. Hang on just a second. Whoa. Let me go find this somewhere. Where did you go, little code? Aha, there you are. Make you feel better seeing other people trying to figure out what they're doing? Yeah. Okay. Here's how to undo hide button. How about hide undo button? All right. Guess what? Now, this method enabled, notice it takes on the value true or false. And notice I have to pass it a parameter. What are we going to? If you call the button that undoes things, undo button, then this is how you'd phrase it. Or if you didn't change the name, and that's okay, every once in a while, a weird thing happens when you're naming things and renaming things, etc. And I wanted to talk about that later. So if yours is just like button 2 or button 4 or whatever, that's okay. You say button 2 dot enabled equal true. Okay, that makes it work. That makes it visible. That makes it function. Now, what if you want to gray out that button? What if you want to disable that button? Well, guess what? You set enabled to false. So now, where you do that is the key idea, of course. You're going to make sure that it's enabled anytime after you've entered valid input, But once you undo something within the method, within the method where you undo, then be sure to disable it until such time that you'll re-enable it. And be sure to test these things. Make sure that you've gone through it too, and you can add things. Every once in a while, I was testing people's assignment 11, and I'd undo something. It would show it on the screen fine, but then I go to add something else, and it didn't really remove one or the other ones from the internal running total. Check it out. Now, if you want to be really slick, you can deal with 2 buttons. Enable one, disable the other, disable the one, enable the other. Yeah. Okay. So it's the same idea. It's this enabled method. It works with, it works with buttons. It works with any kind of action, really. True is enabled, false, disabled. Where to put that is a key idea. Any questions? No, I'll go back here. Any questions on either of those or what's expected in assignment 13? What's expected is perfection. We can do it. I told you the catbird just really mimics actual HR. All right. We do technically have a few more minutes. Let me, I want to preview something that's going to happen next week. Next week, I'm presenting at a conference many states away from Wisconsin. Monday, my plan is to be with you, but to do that from the motel room in St. Louis, Missouri. What do you suppose? How quick do you think Drury Inn, how good do you think their internet connection is? All right. I do have a backup plan. So don't worry about anything. I'll post stuff. A week from Wednesday, next Monday is October 10th. Just from your perspective, hopefully nothing will be different. I just won't be in Wisconsin. Okay? But a week from Wednesday, October 13th, I can't meet with you at our scheduled time. So there'll be something to do. There'll be, right now, my plan is to have a couple software engineering professional society videos for you to take a look at and to do something related to that. Okay, question, Nathan? Go right ahead. If you're talking, I can't hear you. By the way, did I share with you that, my internet connection at my home is a whopping 10 megabit per second. Yeah, okay. I have no idea. I think most motels are probably better, so we'll be okay. All right, good. So this week, everything as normal. I will be with you on Wednesday, Lord willing. And I'll alert you more to that next time, and we'll post something on Blackboard so nobody's surprised what happened. You raised your hand with the emoji, I believe. Oh, wow, really? The emoji did that? Weird. Okay. Yep. Sorry. Hand was raised, but it's okay. All right, folks. If you have a question or a specific comment or concern, I'm going to hang around here, but let me stop the recording. But before I do that, let me say thanks for your hard work. Thanks for being here. Have a great day. Have a happy Tuesday. I will see you on Wednesday.